Okay, so I'm going to go through a couple of example questions based on uniform circular motion. I'll present these questions at the bottom of the video. Question 1. A car is travelling around a circular racetrack at 100 kilometers an hour, with a racetrack having a radius of 30 meters. A. Find the centripetal acceleration of the car. So our first step in this example is to convert 100 kilometers an hour into the standard units, which is meters per second. So we can write kilometers per hour to meters per second. Now, to get kilometers per hour to kilometers per minute, we divide by 60. That gives us kilometers per minute. Then to get kilometers per second, we divide by 60 again. Now, our final step, to get meters per second, we times by 1,000. So we get meters per second. Now, with our original units of 100 kilometers an hour, converting that to meters per second using a calculator, we get V equals 27.77 meters per second. Okay, so that's the first step. We know V. Now, for centripetal acceleration, we know the formula of acceleration is equal to V squared over R, with R being our radius of 30 meters. So we just substitute these values into the equation. So V is 27.77, R is 30, and using a calculator again, we get the value of 25.72 meters per second squared towards the center of the track. Now, we must remember that acceleration is a vector quantity, and that's why we have the direction nominated as well. Okay, let's move to part B. If the car has a mass of 800 kilograms, find the force that is exerted by the tires to maintain the acceleration. Now, the tires are the component of the car that provides that force, so that's what we're looking for, and we can use Newton's law for that. So F equals ma. Now we have just found A, and we know m given in this part B, so it's a matter of substituting the values. So the mass is 800, the acceleration is 25.72, our result is 20.58 kilonewtons. This is also a vector quantity, so we must write the direction, which is towards the center of the racetrack. Okay. Now, part C. Find the period of the car. Find the period of the car in its circular path. In this example, is how long it takes to complete one lap. So we know our formula for the period is 2 pi r. That represents the circumference of the circle, or the distance of the racetrack, one lap, divided by the velocity, the magnitude of velocity. So that's how fast it is going. Now this makes sense because we are working out the distance divided by the speed, giving you the time around the track. So we can just substitute the values that we know. So radius being 30, this velocity value being the converted value of the velocity from 100 kilometers an hour, which is 27.77. Now, using our calculator, 188.5 over 27.77, which is equal to 6.78 seconds. Okay, we've got a second question here. It's a bit hard to read the question, but it will be at the bottom of the video if you can't read it. An object of mass 2 kilograms is rotated in a horizontal circle on a cord of length 1 meter. The cord will break when the tension in it becomes 500 newtons. The speed of rotation is gradually increased from 0. A. Find the speed at which the cord breaks. Okay, so I usually start questions like this with a diagram, and with the diagram you can see the concept and what is actually happening and what you have to work out. So, in a horizontal plane, the object is rotating around, with the center being the radius to the edge of the circle. So, we know what the radius was 1 meter. So I'm just going to write an R for radius. An object is on the M end, and the object has mass 2 kilograms. With the velocity of the object being perpendicular to the acceleration as it is in a uniform circular motion. Okay, so what do we know? We know the force, the mass, and we need to find the acceleration, so we can start with that. So we know the formula from Newton's law, being force equals mass times acceleration. Now, we need to find the acceleration, so we can rearrange the equation. So acceleration equals force divided by mass. Now, we know the force is 500 newtons, and the mass is 2 kilograms. So we get an acceleration equal to 250 standard units, meters per second squared. Now, what we need to find is the speed. So we can use the formula for uniform circular motion, being acceleration is equal to velocity squared over the radius. And we know those values. And we know we need to find the value, the speed. We need to find the speed, which is related to this term here, so we can rearrange the equation. So v squared equals a times the radius, and v is equal to acceleration that we worked out before times the radius. So we can substitute these values, and we get 250 times radius, which is 1, which gives us an answer 15.8 meters per second. Tangential to the path of travel, as this is a vector quantity. So what this tells us, find the speed at which the cord breaks. So the rotation of the mass on the cord increases in speed until it reaches 15, where it's still not broken, and it keeps going a little bit faster, and at 15.8 meters per second, tangential to the path of travel, the cord breaks. The question is looking for the speed. We do know the direction of the velocity, so we can add that in as extra information.